This is Dr. Holt. This video is on AP Physics C. This is for the AP review, and this is on vectors. When talking about vectors, the first thing we need to do is define what a scalar is. Go ahead and get the highlighter out here. The scalar is any quantity in physics that only has magnitude. A scalar value will have magnitude but not have any type of direction associated with it. The magnitude will just be a numerical value. So some examples here: speed is a scalar, distance is a scalar, age is a scalar, and heat is a scalar. And I'm going to go over some other ones. Now, it's very common on the AP exam for them to have a simple multiple choice question where they list several items that are covered in physics and ask you which ones are possibly scalar quantities and which ones are going to be vector quantities. Now, a vector is anything that has magnitude and direction. And usually, in not all cases, but you're going to see the arrow across the top, and that refers to that being a vector. A few of them here would be velocity, acceleration, and force. And again, you notice this vector I have drawn here, it has a magnitude of 40 meters, but it has a direction of 35 degrees coming off of the horizontal axis, and it's going counterclockwise. So that's what I mean by having magnitude and direction. It has these two values right here. So I would make sure I know this. Again, scalar quantities, these two are often missed here. I guess actually three of them: work, energy, and power. Those are all scalar quantities. The vector quantities are the ones that we're more familiar with. Displacement is a vector. Velocity is a vector. Acceleration is a vector. Momentum is a vector. Force is a vector. Lift, drag, thrust, weight. Those are all vectors, again, because they have magnitude and direction. Here, energy, work, and power only have a magnitude. They do not have any direction whatsoever. So I would make sure in preparation for the AP exam that you would know these and know all of these here. Okay, adding vectors graphically. There's often going to be at least one problem where they're going to show you two vectors and they're going to have you add those graphically. Again, to do that, remember, you always add from head to tail. So if I want to add this vector here that has 50 meters a second, it's coming off at 50 degrees. I don't know why this shows 50. Let's put the 50 over here. That'll make more sense. 50 over here. And I want to add those two. I would bring this one right over here. I would go head here to tail here. And then the resultant would go from here, tail, tail, get a vector quantity, to head, head here. And let's change that color. Make it thicker too. That is going to be the resultant right here of the addition of this vector and this vector. Now note, it makes no difference which ones you add first. If I take this vector here, I'll put it right here, and then add this vector here. Again, you notice you're going to get exactly the same result. It doesn't matter which in order of operation. It makes no difference whatsoever. But that's how you're going to add vectors graphically. Now here you have A plus B plus C, and we want to add these graphically here. Again, it doesn't make a bit of difference whether you do C plus B plus A or A plus B plus C. You're going to get the same result. So again, just choose one. This would be A. I will draw B over to here like this. I will grab C over to here like this. I'm going to bring this a little bit down so you can kind of see this whole thing here. You can fairly get this in here. Again, the resultant vector would be from where I started to my point here. Again, you end up tail, tail here, head, head here. This would be the resultant vector, and again, I'll change the thickness and change the color. Okay, so that's how you add A plus B plus C, or B plus C plus A, or C plus A plus B. It doesn't make a bit of difference. And again, you could get the direction if you needed to. Okay, if you get in a situation like this where it says negative 2A, What you want to do then in that case is you want to create yourself a new vector here that's twice as long as A, but going in the opposite direction. So I'm going to do this kind of roughly. So this represents a negative 2A here. I'll make it orange or something. I'm going to give it some extra thickness here. So this orange one represents negative 2A. B, we're going to leave the same. C, I just need to reverse this. So I'll just reverse this vector here. I think I can do it with properties. I'll change the end going back the other way. So this one represents a negative C. Then to add these, I would just grab this one here, which represents the negative 2A. I would add it to the B. I'm going to actually move this around because I can tell I'm going to go down below. Do this again. So this is negative 2A plus B. And then the C would come back over here just like this. And again, the resultant would come back from where I started, which is going to be right here, to right here. That would be the resultant vector right there. Again, I'll change the color of it. And we'll make it, I don't know, make it blue and change the thickness. Okay, so get this rid of this one. So minus 2A plus B minus C. Again, I started here, I went this way, and then I go back to the from where I started. You have to be tail here. You have to end up head here. This would be the resultant vector here. Here's a problem that I've seen missed quite often on the AP exam. You're given two vectors here, 4 newtons and 5 newtons, but you don't have any direction here. And the question is, what is the smallest value you can get if you add FA plus FB? And what's the largest value you can get? Okay, now if you want to find the largest value you can get, and we're only looking for magnitude here, we're not looking for direction. Okay, now I could make myself a vector that goes back the other way, and we'll call this vector, this is going to be f of a, but it's going to be 4 going back the other way. And again, I'll change the value of it so it gives some thickness here. I'll make it orange here and make it thick here. Okay, if I add the two together, then I can put them tip to tip. So the largest value I could get by adding them would be 9 newtons here. That would be the largest magnitude. Now, a lot of people will say, well, the smallest value, I bet I can add these two together and get 0. Well, you can't do it, because if you notice here, get rid of this one for a second, if I add these two together here, then the smallest vector I could get would be going back the other way, which would be 1 going to the left if I did it that way. So 1 newton would be the smallest. I can get any combination between 1 newton and 9 newton by just changing the angles and adding these two together. So be careful on that one. Don't fall for that trick that you often see on the AP exam where they ask you for the smallest, and again, some students will say 0. Another one that you could possibly see would be, they could ask you, what's the smallest angle I could get here? And say you know the magnitudes of A, B, and C. None of these, let's say none of these are right angles. And they say, what's the smallest angle I should get? If that's the case, make sure that you know how to do the law of cosines. And I'll make this, we'll label the angles. This would be big B, this would be big C, and this would be big A here. So let's say I want to find out what the smallest value I can get here. Just go back to the law of cosines, which says that b squared, opposite of the angle, is equal to a squared plus c squared minus 2ac times the cosine of big B. And all you'd have to do in this case is solve for b, and you can find out what the angle would be, possibly would be here, if you knew what the other magnitudes are. All right. Again, you can do this with angle A too, and all the difference would be you'd put A squared here, and you put B here and B here, and then put angle A here. All right. So make sure you know how to do the law of cosines. Adding vectors together mathematically, I don't think you'd have too much problem in this. If I want to add these two together, then what you want to do in this case is find out what the horizontal components are going to be. Again, these are velocities, so I'll make this velocity. I started to do force, but summation the force, summation of the velocity in the x direction. If I do that, I'm going to get minus 50 times the cosine of 50. I'm getting the horizontal here, plus 60 times the cosine of 42 here. I'm going to add those two together there. That's going to give me my x component here. Then I just sum the velocities into the y direction here. I will get 50 times the sine of 50 plus 60 times the sine of 42. I will get a value here. At that point, just go to Pythagorean theorem, and you can find the resultant by taking this value squared plus this value squared and taking the square root. Again, if you want to get the angles, I'm going to recommend that you draw these first in the direction they're going, and then fall back and do the then do the inverse tangent of this value divided by this value to find a specific angle. Again, I'm not going to work through that. I don't really think anyone's going to have any trouble with that particular problem. Polar notation, I really doubt if polar notation would show up on the AP exam. I would know it. Just talk a little bit about that. You're going to see if it is polar, it's going to be like this. Remember, this right here is the magnitude. This right here would be the direction. So if I want to find that, all I'd have to do would be to draw a vector that has a length of 6 and then make this angle here be 50 degrees. That would give me this one. If it's negative 2, 120, then what I could do would be I would make the vector here. I could show it as 2 here, but then this angle is going to be 120. But since this is negative, I would just invert it immediately and then make it go back this way here. That's what that particular one means. If it's 5 minus 40, then I have the magnitude of 5, and this angle here would be 40 degrees. And again, that's all polar notation is going to be. I doubt if you're going to see that particular problem. Unit vector notation. Remember, I hat represents the x direction, j hat represents y direction, and k hat represents the z direction. And these are just going to give you the components of the vector itself. So example here, a vector is 10I hat minus 20j hat plus 30k hat. If you take this value squared plus this value squared plus this value squared and take the square root, you can get the magnitude of A. And that works the same way for B. If you want to add the two vectors together and find out what the magnitude of A plus B is, you would add the I hats together, add the j hats together, add the k hats together, and then go back and do the and then do the I hat component squared plus the y hat component squared plus the k hat component squared and take the square root of that. And if you wanted to know all the angles, which I doubt would ever be on the AP exam, you would take the sum of the I hat and divide it by the magnitude of the vector itself, and then take the inverse cosine. You do the same thing for here and same thing for here. And again, you would be doing the cosine, the inverse cosines. And again, just another representation that a vector can be written in this component form using I hat, j hat, and k hat. Okay, another thing I would know, let me get a highlighter right here, would be to know how to do the cross product and the dot product. As far as the cross product is, the cross product is a vector that is perpendicular to both A and B. Okay, and again, the direction of the vector can be determined by the right-hand rule. And what I mean by that is if you're going to cross the product of A cross into B, if you take your fingers, you take them, point them toward the direction of A, and then rotate them toward B, your thumb will point in the direction of the perpendicular vector, which in this case would be the direction vector C. Now to do the cross product, I'll get right into a problem here. Basically, you're going to get into what's called the determinant. So to do the cross product of A dot B, I'm going to take my I hat, I'm going to multiply it by AY times BZ minus AZ times BY. That's going to give my I value. Then when I jump to J, I have to negate the J. To negate the J, I negate it, and then it's going to be ax times bz minus az times bx plus k hat, which is equal to k hat, which is ax times by minus ay times bx. Note, you're going to get another vector. Again, it's going to have values of I hat, j hat, and k hat. So that's how you're going to do the cross product of vectors. Now let's talk a little bit about the dot product. The dot product multiplication will always only give you a scalar quantity. It's going to give you a single value. It's not going to give you a vector quantity. The dot product's used to calculate like work when we do those calculations, or electric and magnetic flux, which is outside of AP Mechanics C. The example I have here to do the dot product, all you're going to do is you multiply the I hats times the I hats. So it'd be 3 times 2 plus the 2j values, negative 4 times 7 plus negative 5 times 3. You will get a single value. Now the real value of finding that is it allows you to find out what the angle is between two vectors. So what you would do in this case, you would take the negative 37, you would set it equal to the magnitude of vector A. So you'd have to do 3 squared plus minus 4 squared plus minus 5 squared, take the square root of that, that give you the value of A, times the square root of 2 squared plus 7 squared plus 3 squared, that give you V. Multiply those together, and then that's going to be multiplied by the cosine of the angle. So you take the minus 37 here, you divide it by these values here, take the inverse cosine, and you can find out what the angle is between the two vectors. All right. So in closing, again, this video is pretty much just on the vectors and the information you may see on the AP Physics C. I would go back over this a couple times to just make sure that you know the details. And I hope this will prepare you when you take the test here in just a few weeks. Best of luck.